All right, back to finish up neural communication and neurotransmission. Let's talk about action potential for a second. The direction of the neural impulse can only go one direction, like we talked about. It has to travel from the dendrites into the cell body, down the axon, and then out to the terminal branches onto other neurons. And here's what it looks like in the axon. Okay, this blue is what I kind of call the selectively permeable wall. Now, when you have resting potential and a neuron is ready to fire but has not fired yet, you have an overall positive charge on the outside of this permeable wall and an overall negative charge on the inside. And when those cell walls open up, when a neuron is firing, what you basically have is those positive cells coming into the negative cells and causing this brief electrical charge. Okay, and if it's strong enough, it produces depolarization, which travels all the way down the axon. Depolarization is basically just a brief electrical charge traveling down the axon, and that's what we call action potential. So you basically have like these little floodgates that are opening and closing, opening and closing. The positive ions coming in and then being pushed back out, and that kind of happening all the way down this axon. And that's that brief electrical charge that we're talking about. So as the action potential continues down the axon, it goes back to recharge, and then it will be at resting potential again. So how neurons communicate with each other. So now we're talking about how one neuron communicates with a different neuron. First off, the synapse. Like I said at the beginning of the first presentation, we used to think that neurons were all connected. It turns out they're not. Turns out there is a small junction between the terminal branches of the sending neuron and the dendrites of a receiving neuron, and that small gap we call a synapse. And the synaptic gap is also a term for that small gap in between neurons. So how do they communicate between this gap? Well, now we get to neurotransmitters, and neurotransmitters are something that we're going to spend a lot of time on in this chapter. They are chemical messengers that go across the synaptic gap between neurons and communicate with neurons to kind of make a neural activity happen. So when released by the sending neuron, neurotransmitters travel across the synapse and bind to the receptor sites of the receiving neuron. And that's where they generate a neural impulse, and that's how an impulse goes from you feeling a pinch on your skin, up your arm, to your spinal cord, all the way up to your brain to let you know you're experiencing pain. All these neurons are working together to make that neural impulse travel. And then also, once again, reuptake. This is kind of like the refractory period in a neuron. But reuptake is when a neurotransmitter's reabsorption by the sending neuron and getting ready to fire again. So let's kind of see what this looks like in a little animation here. So this is from YouTube. You can see this. We're going to kind of focus in on the brain here. And what you have is you have all these neurons that look like they're connected. And you can kind of see these neurons firing and firing again, firing again. Right here it shows you depolarization. These are the positively charged ions on the outside going into the selectively permeable walls and creating that brief electrical charge. And then they get sent back out again. Okay, so that's the electrical charge that we're talking about. Now, when you get down to the synapse, all right, so this is at the very end of a terminal branch. These little things that you see here are neurons. Okay, you can see they're not connected. There's a small little gap in between there. And these sending neurotransmitters actually go across and bind to these receptor sites. These things right here are the receptor sites I'm talking about. Okay, sometimes they get absorbed, but the ones that do not get absorbed, that's reuptake, where they go back into the sending neuron. Okay, so hopefully that made it a little bit easier to follow. Here's just kind of a close-up of a synaptic gap. These little, green balls would go over and, connect to the receptor sites, which are right here. And if they do not connect to those receptor sites, reuptake happens, and they get sucked back into the receiving neuron. Okay. So this is how it all looks. Okay. Putting it all together, you have a sending neuron with action potential that travels down the axon. The terminal branches here are connected to dendrites of other cells. These neurons are our chemical messengers that send messages between neurons. And then when chemical messengers are not attached to these receptor sites, reuptake occurs, and they get sent back into the receiving neurons, terminal branches. So that's what it all looks like. One more time, this is a much more basic level. But what you have explained here, and I want to turn the sound down, but basically what you have here are, once again, action potential happening, coming down the axon. Now we're to the terminal branches, where these neurons are going to get sent out. And when they get sent out, over here, these are our receptor sites. So if they fit, because not all neurotransmitters are the same, if they fit on those receptor sites, then they'll attach and basically send that electrical charge onto this next neuron. Okay, and any that are left, reuptake happens. They get sent back into the receiving neurons. And these are basically how neurons communicate. So we'll kind of fast forward down here so you can kind of see the reuptake happening. Okay, where they go back into the receiving, or go back into the sending neurons, terminal branches. And we'll kind of move on here. Now, the one thing that I wanted to show you about neurotransmitters, because there are a few questions about this in the neurotransmission worksheet, is all right here. These are the major ones that we're going to focus on. Acetylcholine, dopamine, serotonin, norepinephrine, GABA, and glutamate. Okay, this is a really good chart. This is in your book. It's in the notes that are posted on My Big Campus. We are going to talk more about these when I get back, but just wanted to give you this chart so you could see how they affect the body, which ones are associated with which emotions, and this is kind of where we'll start when I get back next week. So hopefully this will help you kind of get started on that neurotransmission worksheet, and we'll pick up with this when I return next week.